Hello everyone. Good morning to all of you. Welcome back to Maths by Harshit. In this video lecture, we will discuss the remaining question of continuity chapter. In this video lecture, we will discuss question number 4, 5th, 6th and 7th and 8th. Okay, so without further ado, let's get started. Question number 4, prove that the function fx equals to the x raised to the power n is continuous at x equals to n, where n is a positive integer. So we need to prove that this function is continuous, where n is a positive integer. Okay, so first of all, what we have, f of x is here x raised to the power n we have, and the domain of this function is complete real number because it is defined for complete real number. Okay, here n is a positive integer, or we can say natural number. It is a positive integer. So now what I will do here, for complete r we need to show that this function is continuous. Okay, so how we can prove? Let us choose, let a is any arbitrary real number. Okay, okay, now if a is any arbitrary real number, for continuity what we need to find? LHL we need to find, RHL we need to find, and then function value at a. Okay, so what is LHL? LHL is limit x tends to a negative f of x, limit h tends to 0 f of a minus h we have, limit h tends to 0. What is f of a minus h? We need to find by this one, a minus h raised to the power n. Okay, so by binomial theorem, if we expand this, okay, what we are getting? See, limit h tends to 0. Okay, so if you expand this by the binomial theorem, what we get? NC0. Okay, and we can write it as limit h tends to 0 a plus minus h whole raised to the power n. Okay, NC0. Okay, NC0 a raised to the power n and minus h raised to the power 0, that is finish. Okay, after that we have NC1, yeah, a raised to the power n minus 1 and minus 1 h raised to the power 1, up to so on. If we are proceeding, NCN a raised to the power 0 and minus h raised to the power n. Okay, so now we can apply here limit. Algebra of limit will be applied. First limit apply here, and then here it will break. So here there is no term, and NC0 is 1, so it is only a raised to the power n, and rest of the term will be 0 plus 0 up to so on, it will be 0. So hence the limit is a raised to the power n. Now similarly we can find, this is a RH, we can find, this is our equation first. Similarly we can find RHL. What is our RHL? RHL is limit x tends to a positive f of x we have, and limit h tends to 0 f of a plus h we have. Similarly, similar process here also. What we have? Similar process, limit h tends to 0. So we have here a plus h whole raised to the power n. Again binomial theorem we can expand this, and if we are expand by the binomial theorem, again we are getting a raised to the power n. Then that line you need to write. Okay, so here RHL is also this one. Now if LHL is this one, RHL is this one, the function value at a also a raised to the power n. This is third equation. Now from first, second and third equation, we prove that LHL equal to RHL equal to f of a. Okay, LHL equal to RHL equal to f of a. Okay, so implies that f is continuous at a. Now here we prove that it is continuous at a, but a we choose arbitrary number, since a is any arbitrary real number, this implies f is continuous on R. That means it is continuous in its domain. In its domain, it is continuous. I hope you understand this question. Move on to the next question. Now, in the question number 5th, we have, okay, let me take this one. You can do this one. Where do we have, if the function f defined by f of x equal to, it is a piecewise function. If x less than equal to 1, we have x. If x greater than 1, we have 5. Okay. First of all, we need to check is this function continuous at 0. Okay. So, to continuity at 0, LHL we need to find. LHL. Okay. First part I am taking, A part. LHL, limit x tends to 0 negative, f of x we have, limit h tends to 0, f of 0 minus h, that is minus h, as h is a very small positive quantity with respect to 0 and minus h is less than 0. So here in which branch this minus h is lies? I think here it is lies or not. So what we have, limit h tends to 0 minus h simply. Okay. Now we have, if you apply limit, we get LHL equal to this one. Now RHL we need to find. How we can find RHL? Limit x tends to 0 positive, f of x we have, limit h tends to 0, f of h we have, and here again we observe that it lies in f of h. Actually, what is happening here? This is your 0. So the 0 plus h, 1 is here, minus 1 is here. The 0 plus h, we are checking in its neighborhood. Things we are checking in its neighborhood. H is not like that it exceeds 1. It is always before 1, in between 0, the h, 0 plus h is in between 0 and 1. And 0 minus h is in between minus 1 and 0. That's why I took that here. And the same as that 0 plus h is, should be, again we can use this one piece, limit h tends to 0, h we have here, and here we get 0. This is your RHL and this is your LHL, and hence function value at 0 we need to find again by the above one. What we get? 0. Hence from all these three things, what we get implies that LHL equal to RHL equal to function value. Okay. If we have this thing, implies that f is continuous at 0. Okay, first part is complete. Now what will be the second part? Second part, they are saying that at x equals to 1, we need to check is this function is continuous or not continuous. C part you need to do by yourself. Okay. For mid one part I will do, the B part. Okay. At x equal to 1. Now same thing we need to do. LHL we need to find, limit x tends to 1 negative, f of x we have, limit h tends to 0, f of 1 minus h we have, limit h tends to 0. What is f of 1 minus h? Where it is lies? 1 minus h is lies in the first piece, and it will be 1 minus h, same as. So it is 1 minus h, and if you apply limit we get 1. Now we have a RHL. What is RHL? Limit x tends to 1 positive, f of x we have positive. Positive should be just smaller part things. Okay, and limit h tends to 0, f of 1 plus h. And c, it will be lies in the second branch. Limit h tends to 0 f of 1 plus h. Because why so? Because 1 is here, so 1 minus h is before the 1 and 1 plus h is after the 1, strictly greater than. Why so? Because h is a very very small positive quantity with respect to the 1. Okay, so here we have by the second piece we can find the value of f of 1 plus h, that is 5 exactly. So it is 5, and if it is 5, that there is no h value, hence it will be 5 km. So this is your LHL game, that is 1, and this is your RHL game, that is 5. So from both the equation, this is your first equation, this is your second equation, and here I am writing that as LHL not equal to RHL implies that limit x tends to 1 fx does not exist, and if it does not exist implies that f is not continuous at x equals to 1. Okay, this b part is completed. Okay, and the last part you need to complete, that we need to check that the function is continuous at 2 or not continuous. I hope you understand this question. We will move to the next question, that is sixth question. Okay, what they are saying, that find all the points of discontinuity of f where f is defined. Okay, that means first of all we need to check what is the domain of this function. Observe that this is our real line. From 2 and before 2 it is defined already by this piece, and after 2 is also defined by this one piece. So it means that the domain of this function is complete real number. First of all, this thing clear. Now on this domain we need to check where it is continuous, where it is discontinuous. Okay, so actually it has a three part again. We can observe that here we need to write if x is less than equal to 2. Precisely I am taking x less than 2, then x greater than 2, and x equal to 2. Okay, so if x is less than 2, then what we have, f of x will be 2x plus 3 will be the function. Okay, if x is less than 2, so here I will write this is your 2, and before 2 I am saying for this one part. Okay, now any number we will take. Okay, so what is actually the domain is minus infinity to open 2. In this domain we need to check that this function is continuous or not. Okay, first of all, so again what I will do, let a belongs to minus infinity to any arbitrary number I will choose. Okay, because there are infinite number in this domain, and if I am prove for each point it will take a lot of time. Okay, and it may possible that I can't write all the for all the elements, so that's why I'm taking the arbitrary element. Okay, and how we can write LHL, again I'll do LHL is limit x tends to a negative f of x. So if a belongs to minus infinity to 2, so a has to be here, maybe a is here, maybe a is here, and maybe a just close, but guarantee there will be a difference in between. There is a distance between a and 2. Okay, guarantee. Now, so limit x tends to a negative f of x, limit h tends to 0 f of a minus h we have. Okay, now limit h tends to 0 f of a minus h. What do we have of a minus h? F of a minus h we can find by this one, because it is left to the 2. So 2 times a minus h and plus 3. This one we have na. Okay, if we apply limit, what we get? 2a plus 3. This is your LHL and equation number 1. Now what we have RHL? RHL is limit x tends to a positive f of x we have, limit h tends to 0 f of a plus h we have, and since h is a very very small positive quantity with respect to a, Okay, so if a is here and 2 is here, suppose I am taking this one a, which is most closest to a. So if I by the magnifying glass, if I am using magnifying glass here, okay, so it will be look like that. So a plus h should be here, but before to the 2. So again we have limit h tends to 0, and for this a also we have a plus h on the left to the 2. For this a also a plus h we have left to the 2, and for every a which is on the left side of 2, we have a plus h also on the left side of 2. So here again 2 times a plus h plus 3, and if we apply limit, what we get, 2a plus 3, that is your RHL, second equation. Okay, and now f of a, which is also left to the origin, left to the 2, 2a plus 3 we have, 2a plus 3 we have. So we can say from first, second and third equation, LHL equal to RHL equal to f of a, and implies that f is continuous at a, implies that f is continuous at a. And here we need to write the most general thing, that since a is any arbitrary real number in minus infinity to 2, minus infinity to 2, implies that f is continuous, continuous for continuous on minus infinity to open 2. Okay, now we completed the first part, that it is continuous on the left of the 2. Now we need to discuss at 2. Right of the 2 you need to check, okay, left of the 2 I will check. So I checked already. At 2 I need to check b part. At 2, limit LHR I need to find, limit x tends to 2 negative f of x, limit h tends to 0 f of, wait, I will write properly, f of 2 minus h. And for that this 2 minus h, limit h tends to 0, which function we need to use, which one function, the upper function we need to use, that is 2 minus h means 2 times 2 minus h plus 3. Okay, and if we apply limit we get 7 here, first equation. Now we have RHL. Okay, what is our RHL? Limit x tends to 2 positive f of x, limit h tends to 0 f of 2 plus h, f of 2 plus h. And for this one we have function limit h tends to 0, 2 times 2 plus h minus 3, and here we are getting 1. Okay, so from simply what we can say, this is your second equation, this is your first equation. From first and second equation, LHL not equal to RHL. Okay, at 2, implies that limit x tends to 2 fx does not exist, implies f is not continuous at 2. So I hope you understand this question. Okay, That is, we are checking. Actually, listen here. I'll do the one thing. Here you have a 2. Yeah, here you have a 2. This one I completed. At this one position I completed. This one is your homework. Same as that, the first part you need to take x greater than 2, and the function we are using this one only, and hence guarantee this will be a continuous on all the points which are greater than 2, because same function we are using. Hence this function is continuous throughout r minus 2. This is set of continuous function, set of continuous elements. Now set of discontinuous elements are only. So this one is our answer. Okay. C part you need to do. The third part you need to do, that is, you need to show that for every element which are greater than 2, the function is continuous at that point. Okay. You need to do some hard work now. That's why I gave. Now f of x equals to mod of x plus 3. If x less than equal to minus 3, we have this thing. And if x is in between minus 3 and 3, then we have minus 2x. And if x greater than equal to 3, then we have 6x plus 2. Since this one function also, the domain is complete R we have. What we have completely? Complete R we have. Okay. Wait, I'll do one thing. Okay, no problem. I want more pages now, that's why I want to do something. Okay, no problem. We'll do there. F of x is mod x plus 3. This one we have. Now again it have a 3 part, this thing, 3 parts. Okay. How, why I'm saying that it have a 3 part? See this real line. This is our real line. How many points we have? Minus 3, break at 2 points, minus 3 and 3. Before minus 3 and including 3 we have this function, and in between minus 3 and 3 we have different function, the piece price minus 2x, and the third piece is 6x plus 2, which is defined for 3 and greater than 3. Okay. So now what I will do here, the first part I am doing that if our x is less than equal to minus 3. Okay, if it is less than equal to the minus 3, I'll choose. Okay. Now not this one, I'll choose for x less than this one, because at minus 3 it is, see, it is break. For left less than equal to, we define mod x plus 3, and right side we have minus 2x. So it may possible that at minus 3 it will maybe it will be not continuous. Okay, so that's why I took first of all x less than minus 3, for which we have a same function, the what we have, mod x plus 3, mod x plus 3. One more thing you can do here. Okay, no problem, we can apply here also. Okay, see, here you have a two method. Either you can use your LHL RHL concept, okay, for each point which is less than minus 3, and you can say simply LHL equal to RHL equal to the function value f of a, and hence the function is continuous, as we did previously. Or you can say that mod x function, f of x is sum of two function gx plus hx. Okay, so what is our gx, what is our hx? Gx is same as that mod x, and what is our hx? Hx is our constant function, that is 3. Okay, and they both are also defined for all x belongs to minus infinity to open minus 3. Okay, so here we can say mod x, I will write like that, fx, sorry, gx and hx both are continuous, both are continuous on minus infinity to minus 3, implies that their algebra gx plus hx also continuous on minus infinity to open minus 3 implies that fx is continuous on minus infinity to minus 3. I hope you understand this question. Okay, either you can proceed by this one or you can proceed by LHL RHL, it's your choice. Okay, now the second part is at minus 3 we need to check. For this one we need to we need to go by the LHL RHL, because at minus 3 it is defined as piecewise, it will break into two branches. Okay, so it is break into two branches, so that's why I'm choosing this one method. Limit x tends to minus 3 negative f of x, you have limit h tends to 0 f of minus 3 minus h, and limit h tends to 0 minus 3 minus h means minus 3 minus h. Okay, so what the function will define? Left part, that is mod x plus 3. Here I will put minus 3 mod of minus 3 minus h. Okay, and plus 3 is there, and we observe that limit h tends to 0, it will be 3 plus h plus 3, and if we apply limit, then what we are getting? 6 we are getting from here. Okay, now we have RHL limit x tends to minus 3 positive f of x, you have limit h tends to 0 f of minus 3 plus h we have, and limit h tends to 0. For this one we have minus 2 times of minus 3 plus h, this one function we have. Okay, mid one, limit h tends to 0, if we multiply what we get? 6 minus 2h, and if we apply limit, what we are getting? We are getting that 6 only. Okay, so this is our LHL RHL, both are same, hence limit is exist. Now f of minus 3, how we can find f of minus 3? From the first branch or second branch? First piece or second piece? Okay, from first piece we need to find f of minus 3 is, what do we have? F of minus 3, f of minus 3 is mod of minus 3 plus 3, and it will be 6. Okay, so what we have from here? LHL equal to RHL equal to f of minus 3, hence this function is continuous at 3. F is continuous at minus 3. Okay, now the same procedure we need to follow, for the 3 also. So here we can do, yeah, here we can do, we have a space. Okay, the right one part, that is for greater than 3 you need to do. Now LHL, that is third part, we have C at 3, or in between minus 3 and 3 also. Wait, in between minus 3 and 3, it is a very lengthy question. In between minus 3 and 3 we have. Okay, in between minus 3 and 3, how we can proceed? Okay, for this one we have a function is same as that, minus 2x. Okay, so on this domain only we have a minus 2x, so simply we can say fx is a polynomial of degree 1 implies that fx is continuous, fx is, wait, fx is continuous on minus 3 to 3. Done, hence implies that we can say that minus 3 to 3 is a continuous, and before minus 3 is also continuous, but at minus or and also at minus 3 it is continuous. Okay, so how much interval we get? Minus infinity to open 3, this function is continuous. Here I will write at how many points up to that it will be continuous. Wait, I will write minus infinity to open 3, this function is continuous. Now at 3 we need to check is this function continuous or not continuous. D part at 3. Okay, limit wait, RHL we are finding, limit x tends to 3 negative f of x, limit s tends to 0 f of 3 minus h, limit s tends to 0. Now um, for this 3 minus h, how we can define, how we have a function? The function is like that, 3 minus h, the 3 minus h is minus 2, in this branch it is lies, in this piece it lies minus 2x, minus 2x. Okay, so minus 2x means minus 2 here, and 3 minus h is here, and you apply limit, what we get? Minus 6. So LHL is our minus 6, we can observe easily. Okay, it is minus 6. What is our RHL? RHL is limit x tends to 3 positive f of x, limit s tends to 0 3 plus h, and we have function limit s tends to 0 6 times 3 plus h, wait, 3 plus h plus 2, and if we finding from here we get 20, 6 3 18 plus 20. So RHL is this one. So simply from here we can say LHL not equal to RHL at 3. What it implies? This implies that limit x tends to 3 fx does not exist, implies what we have in implication, f is not continuous at 3. Okay, now only one point we are getting from here, that where it is not continuous up to this. Okay, now after 3 also, in the third part, actually we have the first part we have here, the second part we are checking at minus 3, third part we already checked here, and fourth part also we checked here. At 3 it is discontinuous, and the right side we define by 6x plus 2, it is also polynomial, so it is also continuous. So the set we have, set of continuous points are r minus 3, and set of discontinuous points will be, okay, not continuous, we can say not continuous points will be only one point we have, that is this one. Actually they are asking at how many points they are discontinuous, the function is discontinuous. Okay, so I hope you understand this question. Now move on to the next question. What they are saying, that f of x equal to the x. Okay, first of all, f for x not equal to 0 we have mod x upon x, and if x equal to 0 we have 0. So first of all we will redefine it. Actually it is our known function, that is signum function. Okay, so what I have here, f of x you have, and if x not equal to 0, then we can break x greater than 0, x less than 0, and in x equal to 0. For x equal to 0 it is 0, and if x greater than 0, mod x is x, so we are getting 1. This one we have, and here we have minus x upon x, that we are getting minus 1. So simply if we redefine it, if x greater than 0 we are getting 1, if x equal to 0 then we are getting 0, and if x less than 0 then we are getting minus 1. So actually you can do this question by the LHL RHL concept also. See, greater than 0, function is constant, hence it is continuous. Less than 0, function is constant, hence it is continuous. Okay, here and here. But we can observe that at 0 it is not continuous. Why? We can observe by the graph also. The LHL RHL concept you can do for the time being. Okay, that's why I took the graphical method here. See, at 0 value is 0. Okay, after 0, at 0 values, I'll do dark. Okay, and at after 0 we have one value, it is same as that this one. Okay, and before 0 we have minus 1. This is minus 1, this is 1, and this is 0. We observe that right side it is constant, okay, to the 0, hence it is continuous, because without lifting our pen we can draw the graph. And before 0 also this function is continuous, because without lifting our pen we can draw easily graph. But observe that the LHL, okay, I will do for 0, LHL limit x tends to 0 negative, f of x we have limit h tends to 0, f of 0 minus h is f of minus h. H is a positive quantity, so minus h is a negative quantity. Limit h tends to 0, f of minus h, how we can find? By the third piece, that is minus 1, and hence we are getting minus 1. Okay, so the RHL is limit x tends to 0 positive, f of x we have limit h tends to 0, f of h we have, and we can find by the first branch. We can find the thing by the first branch. What we have, that is minus 1. Limit h tends to 0, it is 1, hence it is 1. Okay, so we can clearly observe that from this one and this one, that LHL is minus 1 and RHL is, this is minus 1 and this is 1. So LHL not equal to the RHL implies that limit x tends to 0 fx does not exist, hence this function is not continuous at 0. Simply we can say. Okay, so I hope you understand this complete lecture, in which we are discussing 4th, 5th, 6th and 7th and 8th question. Okay, those questions which I gave for homework you need to do. If you have any doubt in those questions which I gave as a homework, you can ask in comments. Okay, and if you like this video, then please subscribe the channel. Okay, thank you for watching.